So a continuation of that part one, this is part B. So we were looking at example 3, whereby we are given different pieces of information like the vertice and the foci, and we're asked to write the equation of a hyperbola given those characteristics. So I hope you guys by now have done it, and we're gonna just look at how to approach this. So how I approach this is, first of all, I take the information that I'm given and I transfer that information onto a graph. I graphed my vertices, 2, 4, 2, 4, and I wrote V for vertex, and then 2, negative 2, and I said V for the other vertex. And then I went ahead and graphed the foci. Foci. Okay, so I graphed the first focus at 2, 6. So you can see I said focus up there, and then 2, negative 4. And after that, well, I do know that the center is really important because it's the halfway point between the two vertices. And also it's important because it goes into the equation of the parabola. So I utilized the midpoint formula. I had to look it up. And the midpoint formula, I actually checked, I did it twice just to check using the vertex points and the foci points, and I did get that the vertex was at the same location. What I did after that is utilize my focal length formula, which is c squared equals a squared plus b, keeping in mind that a squared is the distance from the center to the vertex, b squared is the distance from the center to the co-vertex, and c is the distance from the center to the focus. So I plug in what I know to, and then, look for what I don't know. And at this point, I noticed that, a squared is the distance from the center to the vertex. Do I know that distance? That's 1, 2, 3. 3, square that. That gives me a squared, which is 9. C squared is the distance from the center to the focus. Just count up. 1, 2, 3, 4, 5. Wait. Is that a 6? Let me count that right. So center to the focus. 1, 2, 3, 4, 5. That's 5. So 5 squared will give me c squared, which is 25. I solve this. I have all variables but one and only one equation. Only one equation. I'm able to find that b squared equals 16, which means b is 4. And b is the distance from the center to the co-vertex. So I can just start at the center and count out 4 distance spaces. 1, 2, 3, 4, and that's 4 units out, which gives me that distance of b, and I can go both ways. At this point, I have 2b. That's one of the b's, and this is the other b's. That's why I say I have 2 b's. I can draw my rectangle, and I already was told where the vertex is. And at this point, once I have the rectangle, I can go ahead and sketch the asymptotes. After I have the asymptotes, it's there. If I'm asking myself, where do I draw the hyperbola? I know that the hyperbola, the vertex is a point on the hyperbola. So if I have the vertex right here, then I know that I draw my vertices up and down. But the question was not graph. The question was, am I able to write the equation of the hyperbola? So from the picture, I'm able to tell that this is a hyperbola that's along the vertical axis, or something that is parallel to the y-axis, which means the y will be the positive part, and a always stays on the first in the denominator of the first input there. And there's a typo here because a squared needs to be, from our calculations how we counted, a squared was 3, because a is the distance from the center, to the vertex, and that was 1, 2, 3. A is 3, a squared is 9. So this needs to change to 9. I was getting ahead of myself. And then, after that, I combined the 2 with the negative. And on the x part, where did I get the 2 from? The 2 was, the x part, the h, basically the x part of the center. And remember, that was 2, 1. That's why I have a 2 there. Close the parentheses, squared, divide by. And then what goes here is b squared. And b again is that distance from the center to the co-vertex, which is what I was solving here. I was solving for here, and now b squared equals 16. I just go ahead and grab that and put it right here, equals 1, and voila, I've got my equation on the standard form of the equation of the hyperbola. Now moving on to other things, how do we change from general form to standard form? So general form is when we have everything looks like it's expanded out. So first, you have to group the like variables and move the constant, and then you need to factor out the leading coefficients from the squared term, and this can be from the x term and then from the y term. And then you have to complete the square for both variables, and last but not least, you need to divide by the constant in order to make that leading coefficient a 1 basically. So here's an example. 3x squared minus ay squared minus 12x minus 48y minus 84 equals 0. We need to write this in standard form. So why don't you guys take a minute or two, or however much time you need, and try it, and then we'll talk about it in a few minutes. Okay, I attempted it as well, and so this is how I approached it. I basically followed the steps that were given to guide me into what I was doing. So first of all, I take the general form as it is, I rewrite it up there so I have it on my page, and then I gather the like terms. So I begin with the x's, so 12x minus 3x squared minus 12x, and then I take everything else on the right side. The next thing was to get rid of that the leading coefficient that's attached to the squared term. So I need x squared by itself, and it's attached with a 3 there, which is attached by multiplication. The inverse operation is to multiply by a third. And since 3x squared is combined with 12x, it affects everything in that term. And then whatever you do on the left side, you've got to do on the right side. Those are the laws of equality. That's why I went ahead and divide by 3. So at this point, what I do on the right side is I just simplify, basically, divide all the coefficients by 3. And then on the left side, what I do is, the point of dividing by 3 was so that I get the squared term by itself, and this will enable me to complete the square, which is what I'm trying to do here. And I find that the constant that I add to both sides is 4, and then when I factor the left side, I've got x minus 2 squared, and on the right side, I can only simplify by adding the constants, and that gives me a 32. Everything else stays as is. So at this point, I have completing the square. For the x term, I need to do the same for the y. So I go ahead and gather my y terms from the left all the way to the right. And once I arrive here, notice that here they were positive. So when they come over to the left side, the inverse operation is negate both. Okay, once I do that, I'm done with the x term. We can basically go and chill out at the right side. So I negate it and then I bring it over. The next thing that I need to do is get rid of that leading coefficient. So I have 8/3. How do I get rid of that? In order to get at 1, I just simply need to multiply by its reciprocal, which is 3/8. I noticed that I have a negative and a negative. So how do I deal with that? Well, just factor it out as they told us. And then after that, I simplify by basically distributing that to both. And if I am distributing on the left side, I need to do it on the right side as well. Now I am ready to complete the square, and these operations here go towards completing the square. I end up with a trinomial of y squared plus 6y plus 9, which factors out to y plus 3 squared. Have I done anything on the right side? Yes. Notice that when I was completing the square, I added a 9 to the left, so I also need to add a 9 to the right side. So once we're done with that step, we're basically almost ready to rearrange everything to look as the standard form of the equation of a parabola looks like. So at this point, I see I have a constant of -3. I have an x term that's attached with the h and squared, a y term that's attached with the k and it's squared. So the constant needs to be a positive. So I obviously, at this point, I'm like, okay, I need to move the constant over to the left. So I add it to both sides. Hence, I have my 3 here. And then, so after I add it over to the left, I noticed that, okay, so since the constant is on the left side, everything else needs to be on the right. So that's why I go ahead and negate the y plus 3 squared, and then I place it on the right side. At this point, you know, from the formal equation, I know that I only need a 1 as the constant on the other side. That's why I just simply multiply by a third or divide by 3, whichever however way you like to say that, and that will give me 3 divided by 3, which will give me a 1. And on the right side I have to do a little bit more work. So notice that I divide everything by 3, but really I'm just working with the leading coefficients here. 3/8 divided by 3, I wrote it out here, is basically 3/8 times a third, and the 3's cancel out and I end up with an eighth. That means that how it translates when I go to the next step to write everything out is basically x minus 2 squared divided by 8, and then the combining operation there is the negative. I just transfer the negative over, and then y plus 3 squared over 3, and this 3 is the 3 that we were trying to divide by everything from the previous step. At this point, I'm done. I've got everything in there, and if I ask you, will this be a horizontal or a vertical hyperbola, what would you tell me? You look for the positive term. In this case, it's the x, and this tells us that, you know, x is horizontal, so it looks like the transverse axis of the hyperbola will be either along the x axis or something that, or a line that's vertical or parallel to the x-axis. So it will be basically a horizontal hyperbola. Okay, the practice is coming right up, and I'll speak to you guys soon.